Hello, everyone. My name is Uli Sampaio. I'm responsible for community at Elastic from Canada and Latin America. Today, we're having a meetup, and it's a great opportunity for those ones that are learning, like just started with Elasticsearch. Um, I would like to give just some announcements before we get things started. Please uh, try to post the questions for the meetup at the end of the session, and please post them on the Q&A section, not the chat. On the chat, I'll be posting some links, like for you to find the local user group or virtual user group, my email, like ways to contact with Elastic to engage with us, the form for you to fill out and be part of the raffle that we're doing for the Bluetooth speaker. Um, Here's just like a Q&A, like I'm sorry, a QR code for you to find. If you're not in our user groups, please join, and then you get like notifications about upcoming meetups that we're planning. After this one, we're having a second part next week, and Liz is going to be presenting about that. Um, and yes, I think, did I cover everything?
Yeah, I think so. Let's see. What about the Slack workspace?
Oh yeah. This is another way for you guys to engage with us. We have a Slack workspace, in case you would like to either post a question or interact with the rest of the community, interact with us from Elastic. This is another channel that you can engage with us. And again, I'll be monitoring the chat. So if you have like any problem or anything, please let me know. And just like I said, for questions, please just wait. At the end of the meetup, Liz is going to have like some time just for questions and answers. And please post the questions to the Q&A. Someone raised the hand, um, but I cannot see who did that. Hmm. I can only lower hand. I'm sorry. I don't know what. I don't know. Yeah, I'm sorry. Whoever raised a hand, like Zoom is not allowing me to see whoever was. Please reach out to me, like message me on the chat or the Q&A. And and yes, I think we're good to start. Lisa, everything's with you now. Thank you again.
All right, thanks, Julie. Hi, everybody. Welcome to the Beginner's Crash Course to the Elastic Stack. My name is Lisa Jung, and I'm a developer advocate at Elastic. So today, I'm going to give you a crash course on Elasticsearch and Kibana. And I'm going to kick this off with a question. So who here has ever used the Elastic Stack before? So in the chat window, type yes if you have ever used it, and type no if you have never used it. I'm going to give you guys about 10 seconds to answer. All right. So it seems like a lot of you have never used it before. And even so, you may be using a lot of apps with certain features that are powered by the Elastic Stack. For example, if you have ever searched for a ride on Uber, Elastic is the engine that powers the Uber marketplace that connects you to the driver. Now, if you have ever had mad cravings for tacos and were searching for open restaurants on Yelp, Elastic is powering that search. So it's hidden under a lot of the apps and websites that you use on a daily basis, which few of them are shown here. So what is the Elastic Stack exactly? Now, if you're a developer working with data, the Elastic Stack is a great tool to have on your belt. Now, it consists of 4 products: Beats, Logstash, Elasticsearch, and Kibana. And with the stack, you can take data from any source in any format, then search analyze and visualize it in real time. So some of the most popular use cases for the Elastic Stack are logging, metrics, security analytics, and business analytics. For example, the Elastic Stack is used to store and analyze log data. And a specific example for all the gamers out there, Blizzard uses the Elastic Stack to analyze gamer and server events. So if the players experience a slowdown or an error, their monitoring team would use the Elastic Stack to figure out what's causing it. Now, it could be also used to gather metrics. And one of my favorite examples is a Mars Curiosity rover, and it sends telemetry, sensor, and photo data into the Elastic Stack for analysis. So if someone wanted to know how hot Mars is on an hourly basis, you can go and pull the data. Now, with the Elastic Stack, you could analyze security issues and threats within an environment as well. So you probably have used Slack at work or at meetups before. And what you may have not realized is that Slack uses the Elastic Stack in their security operations center to secure communications through their channels. Now, lastly, if you have ever used Tinder, you probably didn't realize that the Elastic Stack was helping you find your match. So this is a technology behind using geolocations to match people together. And it's also used to analyze business needs and build custom applications so you can analyze and learn from the data. For example, Tinder relies on the Elastic Stack to analyze and predict which people a user will swipe right on, or which people will swipe right on that user, and when there's a match. So all of these use cases are made possible by the Elastic Stack. And with the stack, you can take data from any source in any format, then search, analyze, and visualize it in real time. And it's a collection of 4 products. So first, we have Elasticsearch, which is the heart of the Elastic Stack. And it allows you to store, search, and analyze your data. Then we have Kibana, which is a visualization tool. And it's a UI that helps you visualize and explore data in Elasticsearch. Now, in order for us to work with data, we need to get data into Elasticsearch, right? And this is where Beats and Logstash come into play. So Beats are lightweight data shippers that push data into Elasticsearch. And if you need to parse and enrich your data before pushing data into Elasticsearch, then you would use Logstash. So Beginner's Crash Course is a series of workshops, and throughout the series, we'll delve into each product, learn when to use it, and how to use it. So by the end of the series, you can identify which products of the Elastic Stack would best serve your use case and know how to get started with these products. And today, I'm going to introduce you to Elasticsearch and Kibana. So here's the game plan. We'll start by going over a scenario where Elasticsearch and Kibana could come in handy. Then we'll go over the basic architecture of Elasticsearch, and we'll wrap up by running CRUD operations with Elasticsearch and Kibana. So let's get started. Now, Elasticsearch is known as the heart of the Elastic Stack, and this is where you could store, search, and analyze your data. So let's go over a scenario where Elasticsearch may come in handy. Now imagine you're the lead developer responsible for building and maintaining an online grocery shop. And using the search bar, millions of customers will be searching for products that they want to buy. And a great search experience is key to have your customers to buy and keep coming back to your platform. And we want customers to get fast and relevant results no matter the scale. Now, another important factor in search is relevancy. So the whole point of search is finding relevant data fast. And we want to be able to fine tune our search experience to get the information we want. And we also want most relevant results at the top and the least relevant at the bottom. So for example, let's say a customer is searching for peanut butter and there are a ton of different brands. But what if a customer wanted to see peanut butter from highest to lowest brands? Or what if the customer is searching for sriracha hot sauce and misspells it? We still want to pull up relevant search results, even though the customer spelling doesn't exactly match the product data. So, if you're in a situation where speed and relevance of your search is an important aspect of your work, Elasticsearch could come in really handy. So, how does it look when Elasticsearch is connected to your app? Well, when a user sends a search request from your website, the request is sent to the server, which sends a search request to Elasticsearch. Now, Elasticsearch finds and sends the results to the server, which processes the info and sends the results back to the browser. So let's go even one step further. Now, through your app, you're collecting a lot of data, such as order information, purchase history, the list goes on and on. And we want to make use of that data. For example, we want to know what was the revenue for the last month, or which products are most popular. To answer these questions, you can enter relevant data in Elasticsearch. So you could search and analyze your data to answer your questions. But data is so much easier to understand if you could visualize it. And this is where Kibana comes in, which helps you visualize and manage your data. So think of Kibana as a web interface to the data stored in Elasticsearch. So it allows you to search, view, and interact with your Elasticsearch data. So if you had a question about what is the most popular product, or what was our revenue last month, you would enter relevant data in Elasticsearch, and from Kibana, send search requests to Elasticsearch to get and analyze the data you want. So on top of that, you'll be able to create a dashboard with Kibana. So you could visualize data in a variety of charts, tables, and maps. And this way you can get insights more easily and be able to share that with your stakeholders. So if you're in a situation where you need to analyze and visualize data inside Elasticsearch, Kibana will come in really handy. Okay, so now that you understand when to use Elasticsearch and Kibana, we'll move on to the basic architecture of Elasticsearch. Now, Elasticsearch is a powerful search and analytics engine, and it's known for its distributed nature, speed, and scalability. And this is due to its unique architecture. Now, when Elasticsearch is up and running, you now have an instance of Elasticsearch, also known as node. Now, each node has a unique ID and a name, and it belongs to a single cluster. And we'll get to what that is in a bit. So when you start up a node, a cluster is formed automatically, and you can have one to many nodes in a cluster. And these nodes are distributed across separate machines, but they all belong to the same cluster and work together to accomplish a task. So let's really bring this concept home. So think about a team you've been a part of, and your team consists of multiple members who all work together to accomplish a common goal. And your team could divide and conquer by assigning each member one or multiple roles. And these are the roles that you're going to specialize in. Now, your team members may work in different buildings, but you all still belong to the same team. And this analogy directly applies to nodes in a cluster. For example, nodes are members of a cluster that share a common goal, and nodes are distributed across separate machines, but they're still part of the same cluster. Now, nodes are assigned to one or multiple roles, and one of the roles that a node could be assigned to is to hold data. And that is what we'll be focusing on today. So data is stored in Elasticsearch as documents, and a document is a JSON object that contains whatever data that you want to store in Elasticsearch. So let's go back to our online grocery shop example. And we're helping our customers search for grocery items online. So we need to store grocery data in Elasticsearch. So a document for one grocery item would look like this. So in a JSON object, it contains a list of fields or key value pairs. For example, it has name of the product, the category it belongs in, its brand, and price. And things are easier to find when you group them in a logical manner. And documents that share similar traits and are logically related to each other are grouped into an index. So, for example, documents of clementines and carrots would be grouped under produce index, and documents of Malbecs and IPAs would be grouped under wine and beer index. So, to sum it up, indices are used to group documents that are related to each other so we know where to find certain information. So, let's delve into this a little bit more. So, here we have a cluster of nodes, and we have a produce index and wine and beer index. Now, index is not actually storing documents, it's just a virtual thing that keeps track of where documents are stored. So you can't find index on disk. What actually exists on disk is a shard. So shard is where data is stored, and this is where you run a search. Now, when you create an index, one shard comes with it by default, and you can also configure it so that you could create an index with multiple shards that are distributed across nodes. And this is a practice called sharding. And there are a lot of superpowers that come with this practice. So let's say you have a cluster that looks like this, and you want to create a produce index that'll keep track of all produce documents. And when you create an index, one shard is created by default, and the shard is assigned to a node. Now remember, shard is where documents are stored, and the number of documents a shard could hold depends on the capacity of the node. So let's say you want to index 600,000 documents in your produce index, but the node where the shard is assigned to could only hold 200,000 documents. Well, that's not going to work, right? Well, we do have two more nodes which could hold 200,000 documents each. So what you can do is you could add two additional shards in the index and distribute them across these nodes. So each shard could hold 200,000 documents. So together, they could hold 600,000 produced documents. Now that's all fine and dandy, but our produce data is only going to grow. So how are we going to adapt to increasing amount of data? Well, that is the beauty of sharding. You could add more shards and nodes as the need arises. So you could horizontally scale and adapt to increasing number of data. Well, that's not the only superpower that comes with sharding. Now remember, shard is where you store documents, and it's also where you run search. So let's talk about a scenario where the client is sending a search request for pink lady apples. Now, in this scenario, you have one shard in a node that can hold the entire produce index. Now, let's say this produce index keeps track of 500,000 documents, and we're going to run a search in this single shard, meaning we'll go through 500,000 documents sequentially. Now, let's say it takes you 10 seconds to do that. Now, this time, we're going to run the same search with a different setup. So we'll have 10 shards distributed across 10 nodes, and we'll just distribute 500,000 documents across 10 shards so that each shard holds 50,000 documents each. Now, in the previous scenario, it took us 10 seconds to sequentially search through 500,000 documents. Now, if you do the math, running a search on 50,000 documents should take 1 second. And what's so cool about this setup is that you could run search on all 10 of these shards at the same time in parallel. Now, guess how long it takes to search through 500,000 documents with this setup? 1 second. So as you can see, sharding could really speed up your search. Now with the first setup, one node had to store all the info and process all incoming search. And with this setup, we could only store as much data and process search requests as a single machine. Now with the second setup, we distributed data across shards and allow shards to process search requests in parallel. So not only do we have the capacity to store more data, we can now search at scale. So let's say everything is going well with our online grocery shop, but all of a sudden, one of our nodes goes down and our data is lost forever. I mean, that would suck, right? So we want to avoid this at all costs. So what we could do is we can make copies of the original shards and store its copies across different nodes. So look at nodes 1 and 2, and these nodes contain our original shards, also known as primary shards, and that's what P stands for. And we're going to make copies of each shard and store these in nodes 3 and 4. And these are known as replica shards, and that's what R stands for. So R0 is a replica shard of primary shard 0, and R1 is a replica shard of primary shard 1. Now, what this does is that if one node goes down, everything's okay because we have a replica of our data somewhere else. Now, that's not all. There's an additional superpower that comes with replica shards, and that is improving the performance of your search. So let's say we have 2 primary shards distributed across 2 nodes, and you're currently getting 2,000 search requests per second. And these search requests are being ran in these 2 primary shards. And as our app is getting more popular, the search requests have now increased to 8,000 requests per second. And because of that, your 2 primary shards are having trouble keeping up with the demand. So to solve this, you could add more nodes and increase the number of replica shards of P0 and P1. And remember, these replicas are identical copies of the primary shards. And with the new setup, these replica shards can pick up the slack, and your cluster can better handle increased demands on search. Okay, so now that you understand the basics of Elasticsearch, we're going to move on to the tutorial. And we finally get to play with Elasticsearch and Kibana. And the goal of this tutorial is to get familiarized with CRUD operations. In other words, how do we create, read, update, and delete a document from Elasticsearch? So to do this, we're going to use Elasticsearch and Kibana. Now, there are multiple options for accessing these 2 products. So one option is to use Elasticsearch and Kibana hosted on Elastic Cloud. Now, this handles all the heavy lifting of managing the stack, so you can focus on what really matters for the product that you're building. So you get a free 30-day trial, and there's no credit card required, and the trial expires on its own. And I find that for beginners, it's easier and faster to get started on Elastic Cloud. So I'm going to show you how to do that today. Now, another option is to download Elasticsearch and Kibana on your local machine and manage these on your own. And this option is free and there's no expiration date. And I'm going to go over the self-managed option in the part 2 of this workshop next week. Okay, so here we have a link to a GitHub repo for today's workshop. Uli, will you drop this link in the chat?
Yes.
Okay. Now, once she drops a link in the chat, go to this link and have this pulled up. And you'll see this on your screen. So this repo contains all the resources that are shared during this workshop, and the slides and the recordings of this workshop will be included here as well. Now, if you scroll down to the resources section, you'll see the link to free Elastic Cloud trial. So you'll right click on that and open the link in a new tab. Now, the link will take you to the free trial page. And Elastic Cloud hosts Elasticsearch and Kibana as a service. And unlike the downloaded option, it does all the heavy lifting of managing the stack. To get going, enter the email and click on Start Free Trial. And once you do that, it'll ask you to go to the email account you signed up with and verify your email. So go to your inbox and click on the email from Elastic, then click on Verify and Accept button. And it'll prompt you to set your password. And once you set your password and log in, it'll take you to this page where you'll click on Start Your Free Trial. Now, by the way, I'm breezing through the setup section because I don't expect you to follow along during the presentation. I'm just going over this here so that you could follow the recording and set it up if you want to move forward. Okay, so it'll take you to this page where you'll click on Start Free Trial. Next, you'll select the Elastic Stack. Now, when you do that, you'll see this drop-down menu where you can configure your settings. So if you look under Select Hardware Profile, Elasticsearch offers several deployment templates for different use cases and workload. And each template selects the appropriate cloud hardware configurations for different needs. But if you're just getting started or don't quite know your needs yet, then go with the recommended IO optimized option. Then you choose the cloud provider of your choice. So let's say you have an app and you want to integrate Elasticsearch. So if your app is running on Google Cloud, you don't want Elasticsearch running in a different cloud provider because that'll cause latency issues. But for what we're about to do, it doesn't matter which one you choose, just select one. Then select the region close to you and select the latest version of the Elastic Stack, which at the moment is 7.10.1. Now, if you scroll down, you can name your deployment to whatever you want. I name mine Beginner's Crash Course, then click on Create Deployment. Now, once you do that, you'll get your deployment credentials, and you'll need this when you add data to Kibana. So either download the credentials or save it somewhere else, as these are only shown once. And when you click on download or continue without downloading, it'll create your deployment and load Kibana. Now, once everything is loaded, click on Open Kibana. And after that, both Elasticsearch and Kibana are ready to go. And we're going to pull up the Kibana console now. And when you advance to the next page, click on Explore on My Own option. And it'll take you to this page here. So click on menu icon in the upper left corner and scroll all the way down to Management section and click on DevTools. Okay. Then it'll take you to the Kibana console. So click on Dismiss and delete the default query shown here. And now we're ready to use Kibana to send requests to Elasticsearch. So before we get to the CRUD operations, let's take a step back and look at the big picture. So remember, Elasticsearch is a search engine. So when a user sends a search request from your website, the request is sent to the server, which sends a search request to Elasticsearch. Now, Elasticsearch will then find the info and send it back to the server, which processes the info and sends the results back to the browser. And the same process can be mimicked and tested with Kibana, which is a UI that communicates with Elasticsearch. Now, when you deploy on Elastic Cloud, Elasticsearch and Kibana are automatically prepped and ready to go. And the cloud automatically creates multiple nodes that are grouped into a cluster. Now, as you know, Elasticsearch is receiving search requests and sending the results back all the time. And this communication is handled by HTTP requests. So in the tutorial, we'll be learning about the requests that we could send to create, read, update, and delete data in Elasticsearch. So let me get set up here real quick. Okay. So we're going to have two windows open side by side. So on the left, I have the Kibana console open, and on the right, we have the workshop repo. So we're going to go to the browser where we have Kibana open. And this is divided into two panels. So on the left is where we enter the request you want to send to Elasticsearch. And on the right is where we'll see the response from Elasticsearch. So we're going to start out by checking the health of the cluster. So look to the right to your repo and scroll down to getting information about cluster and nodes. So this is a syntax that we're going to use. First, we start with an HTTP verb get, followed by the API that we want to get information from, and the parameter, the information that we want to get from this API. So to get info about cluster health, we're going to use this request. And what we're saying here is get health information from cluster API. So let's copy and paste that. Make sure to select it. There's a dark gray bar over it. And click on this green arrow here to send the request. Now, you'll see a JSON object returned to you. And you'll see that the cluster has this name here. And the status is green, which means that the cluster is healthy. And if you look at line 5, you'll see that we have 3 nodes created for us. Okay, so next, we're going to get more information about our nodes. So scroll down to get info about nodes in a cluster. And the request that we're going to send is get stats about our nodes from Nodes API. So let's copy and paste that into our console. Make sure to select it and send. Now, you'll get a huge response coming back from Elasticsearch. So you could see that we have total of 3 nodes in this cluster. And we also see the IP address, roles, and attributes, and the list goes on and on. Now, we're not going to get into all of this, but this is a great request to know if you're debugging a node, because it allows you to inspect the node more in detail. Okay, so now we're going to move on to the CRUD operations. So in other words, how do we create, read, update, and delete a document? So for this exercise, we're going to store documents about our favorite candy. Now, by now, you know that documents are logically grouped into an index. And as a best practice, we're going to create an index first. So let's go to our repo and scroll down to create an index. And the syntax that we're going to follow is put followed by name of the index. And since we're storing documents about our favorite candy, I'm going to name our index favorite candy, all lowercase. And we're going to copy and paste that into the console. Make sure to select it and send. Now, when you see acknowledge true, it means that an index named favorite candy has been successfully created. Okay, so now that we have an index, let's index some documents. And this time I'm using index as a verb to mean that we're storing documents in Elasticsearch. So let's scroll down to index a document here. Now, when you're indexing document, you can either use post or put. And you would use post if you want Elasticsearch to auto-generate an ID for your document. So the syntax that you're going to follow is post followed by name of the index, then document endpoint, and in a JSON object, include whatever data that you want to store in Elasticsearch. So for our example, what we're saying is post in favorite candy index the following document, and the fields that I have are first name and candy. So let's copy and paste that below. Make sure to select it and send. Now you'll see a 201 response, which says in the favorite candy index, a document with an auto-generated ID has been created. Okay, now turn to your repo and scroll up a little bit here. Now, we said when indexing a document, both HTTP verbs post or put could be used. Now we're going to move on to when you would use put to index a document. So scroll down to put. So you would use put if you want to assign a specific ID to your document. And a time where you might want to use this is when you're indexing data with a natural identifier. For example, let's say you're indexing patient data where each patient has a unique ID, and documents may be easier to work with if it had the same ID as a patient ID rather than some auto-generated ID that has no meaning. So this time, we're going to index a couple more documents using put. So if you look at the repo, the syntax you're going to follow is put followed by name of the index, then the document endpoint, then ID that you want to assign to this document. And you would include whatever data that you want to include right here. So for our example, what we're saying is put in favorite candy index the following document and assign this an ID of 1. So let's copy and paste that here. Make sure to select it and send. Now, you'll see that in index favorite candy, document with an assigned ID of 1 has been created. Now, you'll notice that the version number here is 1. Take a note of that. We'll go over this in a little bit. Okay, so we're going to index a couple more documents, and I'm going to copy the request that we just sent and paste it twice below. Now, for this one, I'm going to assign this an ID of 2, and I'll say Rachel's favorite candy is Rolo. And I'm going to select this request and send. Now we'll see that document with an assigned 2 has been created. And let's do the same for the third one. This one will have an ID of 3. And I'll say Tom's favorite candy is Kit Kat. And I'll send this request as well. Perfect. Everything worked. So now that we have indexed some documents, I want to send a request to see the content of the document that has been indexed. So this is the read part of CRUD operation. So turn to your repo and scroll down to read. And the syntax that you're going to follow is get followed by name of the index, then the document endpoint, then the ID of the document that you want to retrieve. So for our example, we're saying get from favorite candy index document with an ID of 1. So let's copy and paste that right below John's document here. Make sure to select it and send. Now you'll see that document 1 has been retrieved. And if you look under source field, you see the content that we sent in the request. So this is a great way to check whether our CRUD operations have worked or not. Now, what do you think would happen if we accidentally index another document with an existing ID? So let's find out. So go back to the request that we just sent with an ID of 1. Let's copy and paste that below. Now I'm going to say Sally's favorite candy is Snickers. And let's say I forgot to change the ID and we index a document with an existing ID. So make sure to select this request and send. Now, we see a different response, right? So we get a 200 response instead of 201. And we're seeing that document 1 has been updated. And when you look at version, the version number is now 2. So what this version number is telling you is the number of times a document has been created, updated, or deleted. And since we created the document here with John's information, and we accidentally updated the document with Sally's information, the version number is now 2. So let's send a GET request to see the content of document 1 just to make sure. So go back to the GET request that we sent earlier, select it and send. Now you'll see that under source, John's information has been replaced with Sally's information. Now, that's not good, right? Because when you're indexing data, you don't want to accidentally overwrite your existing document. So in order to prevent that, you could use the create endpoint. So turn to your repo and scroll up to create endpoint. And the syntax that you're going to follow is put followed by name of the index, then the create endpoint, and the ID that you want to assign to this document here. So what we're saying is put in favorite candy index the following document and assign it an ID of 1. But if this ID already exists, then don't do anything. Just throw an error. So let's copy and paste this. Right below Sally's request here. Oh, actually, let's do it below the GET request. Make sure to select it and send. Now you'll see a 4.9 error here. And the reason for that is because the document already exists. So the create endpoint worked just as it should. But let's double check and take a look at the content of document 1. So go back to the GET request here, select it and send. If you look under source, you'll see that Sally's information is still there. So the create endpoint provides a safeguard for you so you don't accidentally overwrite your document. Now let's scroll down to update. Okay. So there'll be times where you want to update an existing document. So for example, let's say Sally originally liked Snickers, but she changed her mind. Her favorite candy now is M&Ms. So let's go back to our repo. And the syntax that you're going to use for that is post followed by name of the index, then the update endpoint, and the ID of the document that you want to update. Now, make sure to include doc as a context here. And what this is saying is to only update the fields that are specified in the inner bracket. So here, for example, we're saying post in favorite candy index. I want you to update document 1. But please note that I only want to update the field candy with M&Ms. So let's copy and paste that right below Sally's request here. Make sure to select it and send. Now, you'll see that document 1 has been updated and the version number is now 3. And that makes sense because document 1 hasn't created John's information. Then we accidentally updated that information with Sally's. Then we intentionally updated the field Candy with M&Ms. So I'm just going to double check and send the GET request again to see the content of document 1. So select the GET request and send. Now, if you look under source, you'll see that the field Candy has been updated with M&Ms. All right, so last but not least, what if we wanted to delete a document? And that one is super simple. So go to your repo and scroll down to delete. And the syntax that you're going to follow is delete followed by name of the index, then document endpoint, and the ID of the document that you want to delete. So here we're saying delete from favorite candy index document with an ID of 1. So let's copy and paste that here. Right below the M&M request. Make sure to select it and send. Now you'll see that the document 1 has been deleted and version is now 4. But let's double check as usual and send the GET request for document 1. And when you send that, you'll get a 404 error because document 1 no longer exists. Okay, so those are all the requests that I've got for you. So I know we went over a lot. Does anybody have any questions? Do we have any questions in the Q&A section, Uli?
No, not so far, no.
I'm checking here. Okay, I don't see any questions. Oops. These slides have like mind of their own. No questions so far?
I mean, like, does everyone know that like right now is time to ask questions? Maybe that was not clear.
Oh, maybe that
So
wasn't
now,
clear.
yeah.
Sorry about that, guys.
Yeah, if you have questions, now it's time like to post them on the Q&A. Or if you have any trouble with the Q&A, you can post in the chat and I'll just copy it to the Q&A.
Okay. So I guess we'll move on then. Okay. All right. So we have another workshop in the series coming up, and we'll be talking about relevance and how you can fine-tune precision or recall of your search results. And that's happening next week on Thursday, February 4th at 4 p.m. Pacific time. And Uli will be dropping the event link in the chat. So RSVP if you want to attend next week. Now, if you have any questions about Elastic, the discussion forum is a great place to get your questions answered. So we have a community of developers and developer advocates that answer questions on this platform. So feel free to post your questions here. And last but not least, I often blog about Elasticsearch. So if you prefer to learn by reading instead, be sure to check out my blog. All right, that's a wrap. So thank you so much for coming, and I'll see you later.
Lisa, thank you so much for the clear explanation. It was probably the first time that it was clear to me as a non-tech person.
Okay.
I really enjoyed this presentation. And as you can see from the chat, like people were saying that was very clear. Thank you so much.
That's great.
I hope to see everyone again next week so we can go deeper into Elasticsearch and Kibana. I post the link so you can RSVP and don't miss out the next meetup. And please make sure to answer the Google form that I sent so you're part of the raffle for the Bluetooth speaker. And it only takes 2 minutes to leave a feedback for this meetup. I would really appreciate that. Thank you again. Thank you, everyone. Thank you, Lisa, and see you next week.
Bye, guys.
Bye.